All right, so we're talking about the atoms in a solid and how they're organized. And so naturally a question you might have is, how do we see this? How do we know this? So how do we see atoms in a crystalline solid? And so the technique or the instrumentation that we use for this is called X-ray diffraction. And so basically the simple idea here is that we shoot X-rays at this solid and see how they diffract. So basically what's going to happen is these X-rays are going to hit these atoms and they're going to bounce off of one another. And then we're going to collect these X-rays later on. And so if they bounce and then they recombine, if they're in the same phase, something like this, where you see this kind of up portion is combined with this up portion, they're going to constructively interfere. And so they'll form a bigger signal. Whereas if they diffract, but in opposite ways, so they're not in phase, you can see we're on the top part of the wave here and on the bottom wave of the wave here, bottom part of the wave here, they're going to deconstructively interfere and you'll see no signal here. And so basically this is organized in what's known as the Bragg equation. So I'll write the equation. I'll never ask you to use it or anything like that, but it's n lambda equals 2d sine theta, where n is some sort of integer. So just some kind of number, 1, 2, 3, 4, 5, whole number. Lambda is the wavelength. D is the distance between atoms. And then this theta here is the angle of the diffracted beam. So this picture shows this as well. So here are these little black dots here that you see, those are the atoms. And so you see some X-rays coming in and they're diffracting off of these atoms. And so you can see here that they're in phase. You see it's on the bottom, it's on the bottom. So this will have some constructive interference. And then what you do is you rotate the crystal around. And when you do that, you change the angle of the incident beam. And so you can see here they're out of phase, right? This is the bottom, this is more towards the top. And so they'll deconstructively interfere. And so the overall experiment, you have this X-ray source, and then you're shooting it at your crystalline material, and then it's diffracting all these X-rays off. And so what you end up getting is this diffraction pattern. And basically by using a whole lot of math, you can identify where your solid atoms are at. So you don't have to worry about doing any equations or anything about this. Just know the basics of X-ray diffraction.